Hello and welcome back. So, I'm your instructor Sunil, and I hope you are learning well from this class on MongoDB, and I hope you are learning well. And if you have any question or any doubt, you are welcome to ask all your questions and doubt in the discussion area, and I will be more than happy to answer all your questions. So I have in this class I have covered all the topics related to MongoDB, starting from the basics to the even the map reduce, sharding, everything, clustering, MongoDB on the cloud, MongoDB tools, backup, restore, administration, everything has been covered. And we have also seen two of the projects, one based on the Node.js and other is on the Java. So we have covered almost everything, and I will be going to update this course more often. Whenever there will be update in the MongoDB versions, you will see an update in this class as well. What I'm going to do in this particular lecture, which will be a little big lecture in the time wise, it can be a 10 minutes or 15 minutes lecture. In this we are going to summarize what are the things we have learned. Basically it will help you when you go for an interview, or it will also help you in tackle interviews, and it will also help you in revise the concept that you have learned in this long course. Okay, so let's get started. The very first question people may ask when you enter the interview room, for especially for MongoDB related interviews, what is NoSQL database and what is MongoDB, why we use MongoDB, why we cannot use RDBMS, relational database management system. So we'll start with this basic question and then we'll proceed further. And in this question answer session we will be basically revising what are the things we have learned so far. The first question, what is NoSQL? NoSQL means no SQL. It means no structured query language. So what is structured query language? You know, in RDBMS or in the MySQL or Oracle, what we do, we store data in a tabular form. That means we create a table which will have rows and columns, and first we define the rows and columns, what kind of data it can take, what it can be numbers, string, it can be image, video, whatever things that we decide upfront. That means we first design the schema, we decide what kind of data we are going to store, what size of data we are going to store, and then based on the table that we have created, we store the data, right? So there, when you know the nature of data upfront, you can use no RDBMS databases. But nowadays, in the age of growing data and growing transactions, in the age of social media and internet, we are not sure about the data. We are not sure about how much data we are going to take and how many types of data we are going to get. So we are not sure what kind of data we are going to get and what kind of data we are going to store in the database. That means we are getting dynamic kind of data, like aeroplane, the aeroplane industry, they use a huge amount of data. Every aeroplane, when it is taking off and when it is continuing its journey and it's coming back to the destination, it is sending lots of data, and it is very critical data, and it's a huge data. Like in social media, in Facebook or Twitter or Instagram, we are using lot of data. We are transacting with lot of data. We are sending messages, emails, GIFs, all those things, right? So we are not sure about what kind of data we may expect in this growing data, and in this age of big data, we need a system to store this dynamic nature of data. And in that place, we cannot use MySQL data, because there we have to first design the table, we have to first decide what are the rows and columns we are going to store, and then only whenever a new data comes, new kind of data comes, your database may not going to take that. So in that case we are going to use NoSQL database, and it is dynamic in nature. We need not to decide how we are not going to limit our data. We are not going to limit the rows and column. We just store data in the form of documents. We are going to store data in the form of key value. We are going to store data in the graph data. We are going to use data in form of column oriented databases. So these are the NoSQL databases forms. So basically there are 4 types of NoSQL databases. One is document oriented database, that is MongoDB, then key value database, then graph oriented database, and the fourth one is column oriented database. So whenever there is a dynamic nature of data, we are going to store in the NoSQL databases. There we cannot store that kind of huge big data or huge amount of data that is dynamic in nature, that we cannot store in the traditional databases. That's when we need NoSQL database. So with this we have covered what is NoSQL database and what are the types of NoSQL databases. Next thing is MongoDB. Like we have discussed, document oriented, key value, graph, and column oriented. These are the 4 types of NoSQL databases. So MongoDB is document oriented database. So here we store data in the form of BSON document. BSON is a document structure, and based on that BSON structure we store the data in the MongoDB, like key value pair or key and value, right? So ID and value, like in MongoDB we have seen whenever we are storing name, and then for the name we are storing the value. Okay, so like that we store data in the MongoDB in the document form. And in MongoDB, instead of rows and column, we will have the instead of table we will have the collection, and inside the collection, instead of like in the RDBMS we have table and rows and column, here in MongoDB we have database, then collection, and then instead of rows and columns we have the documents, and inside the documents we store the data in the form of key value pair. Okay, next good question would be what are the most important features of MongoDB database. So the MongoDB database, first thing is it can store a dynamic data. When you want to store, you can use MongoDB, and its data model is flexible. We need not to worry about the data model or data structure, so we can store any amount of data model in the form of documents. The third could be it is very it is not a structured query language, it's a very expressive query language. So we can query the database in a very expressive manner, and it is very faster, and it is very efficient, and it is very scalable database if you compare with the traditional RDBMS databases. And it is very agile, and it is very highly scalable. So we need not to worry about where when it comes to scaling your database. You can very well scale your data in whatever ways you want. So it is very flexible, it is very scalable, it is faster, it is efficient, it is very secure also, and it is very dynamic also. So or whenever you have this kind of transaction data, you can very well go with the NoSQL databases, or in more ways you can go with the MongoDB. Next thing is, what are the languages that we can use with MongoDB? Like MongoDB can be used with almost all the languages, like be it Java, be it Python, be it Node.js, be it JavaScript, be it Google Go, be it Scala, be with Ruby, Python, Perl, PHP, C++, C#, any language you take it, you can use MongoDB with that language. So every language it supports. So, and the next question can be with the what is namespace in MongoDB. So namespace in MongoDB is like a concatenation of database name and collection name. So like when we query a MongoDB, we use db dot, and then we use the collection name dot find, db dot collection name dot find. So, and before that we are selecting the database, use particular database name, use db, and then we are going to use db dot collection name. So namespace in MongoDB is the database name and collection name is the combination of database name and collection name, right? Next most common question is MongoDB support foreign key constraint or not? So the answer is simple no. MongoDB does not support such kind of relationships. Foreign key relationships is not exist in MongoDB. Okay. And then the next question could be how do we achieve for primary key and foreign key relationship in MongoDB if MongoDB does not support foreign key relationship? So the answer is simple. By default, MongoDB support primary key and foreign key relationship. So we need not to go in a specific way to achieve the primary and foreign key relationship. By default, it supports, and that's why I said foreign key relationships are not exist in the MongoDB because it's by default there. Okay. And this we can achieve by embedding one document inside the other document. So embedding document, we can achieve the primary and foreign key relationships. And the next question could be MongoDB need a lot of RAM or big system to work on? So answer is no, it is not required. MongoDB can be run on the 2 GB machine also, and it may require based on your data. So if you are going to like work on a big data or a very huge amount of data, then you may need a big better RAM. But if you want to use for development, you can run on any simple machine, and 2 GB, 4 GB, 8 GB RAM is more than sufficient. And if your data processing is needed much RAM, you can go with the MongoDB on the cloud, and there you can use RAM, and you can use your processing machines based on your requirement. Whenever you need, you can just take it, and whenever you don't need, you can leave it. So based on that, you can use. The simple answer is it does not require a lot of RAM. Okay. And you must be remembering we have discussed about object ID and what is the structure of object ID. Though that is also one very special question in MongoDB interviews, like structure of object ID. Explain the structure of object ID in MongoDB. So object ID in MongoDB is a 12-byte BSON type, and the first 4 types is a value representing seconds. The next 3 byte will be machine identifier, like what are the machine, on which machine you are creating that document, and the next 2 byte will be the process ID, and the last 3 byte will be the counter. Okay. One more important question is when we delete or when we remove a document from the database, MongoDB remove it from the machine also, from the disk also. So the answer is simply yes. When you remove from the database, it will be removed from everywhere. Okay. So from disk also it will be removed. So next question is what are the indexes? So indexes support efficient execution of queries in MongoDB. So indexes will support you to execute the queries in MongoDB more efficiently, like it does in any other databases. So what if when you do not use indexes? So when you do not use indexes, what MongoDB will do, it will perform a collection scan. That is, it will scan every document in a collection to select those documents that matches the query statement. So when you use a query, it will go and look for each and every document inside the collection, and then it will find special based on your query. So when it matches, it will give you the result. Okay. And when you use index, it will just go with that index to limit the number of documents in that search. So it will not go for all the document, it will go for those indexed documents only. Now the next question could be how many indexes MongoDB create by default for a collection? So answer is one index, that is underscore ID. The underscore ID field is an index that MongoDB create by default for every collection. Okay. And that will be unique for each and every collection. Next question could be, MongoDB provide facility to text searches. Yes, MongoDB supports creating text indexes to support the text search inside the string content. Okay, if you have a string document inside MongoDB database, you can create your text indexes and you can search your text. Next question could be, MongoDB, when MongoDB do the write updates to the disk. So every 60 second MongoDB update to the disk. Okay, so for this lecture I'll limit the question till here, and we'll see if you have any more question to ask. You can ask and I will be answering those as well. Thank you. Hello and welcome back. So another important question that is very common during the interviews, and that is also a very important concept in MongoDB as well, and that is capped collection. So they might ask you what is capped collection and what is the purpose of using it, and give an example of capped collection. So in this lecture we are going to cover capped collections in MongoDB. So we'll refer the MongoDB documentations and I will try to get the overview of MongoDB capped collection, and after that we will go for the hands-on. Okay, and I will show you how to create a capped collection and how it works. Okay, so as per the MongoDB 4.2 documentation, capped collections are fixed size collections that support high throughput operations that insert and retrieve documents based on insertion order. So if you try to understand the first sentence, what it is saying capped, as you can see with the name capped. Capped means we are putting a cap on the collection. Cap means we are limiting with something. Okay, so capped collection are fixed size collections. So it is fixed size collection. That means it will be restricted with the size of the document and it will be restricted with the number of document inside the collection. Okay, so both size and the numbers we can restrict. So in that way it will become a fixed size collections that support high throughput operations that insert and retrieve documents based on the insertion order. And how it will work, when you use capped collection, it will give you high throughput when you do insertion and when you try to perform the read operations on the document. So it will follow based on the insertion order. So suppose you are creating a collection with a document, you are capping the collection with the number of document, suppose 5, and suppose you are inserting 1 document, 2 document, then 3rd, 4th, 5th. Now you have reached the maximum size. So as soon as you'll reach the maximum size and when you try to insert one more, that means the 6th one, then what it will do, it will go and it will delete the oldest document. So it will follow the insertion order, and the document which was inserted first, it will be deleted, and the 6th document that you wanted to insert, it will be inserted. So first come first serve. Okay, so the first inserted will be deleted first. So when we have 1, 2, 3, 4, 5 and when we want to insert 6 document, the first document in the current collection will be deleted and the 6th one will be inserted. In that sense, the second will become the first. Okay, so it will follow the insertion order. So oldest document will be deleted to accommodate the new document. Okay, I hope you got to know and you understood what it is saying. Okay, so next thing, what it is saying, capped collections work in a way similar to circular buffer. Once a collection fills its allocated space, it makes room for new document by overwriting the oldest documents in the collection. That's what I said. It will follow the insertion order and the oldest will be overwritten by the new one when the space is over. Okay, or the number of document, maximum allowed document number of document is over. Okay, and next comes the behavior, insertion order. So capped collection guaranteed preservation of insertion order. Okay, as a result, queries do not need an index to return document in insertion order. Okay, without it will follow the insertion order. Without this indexing overhead, capped collection can support higher insertion throughput. Okay, so what happened when you don't index your document, index a collection? What it will do, when you search, it will search for all the collection, then it will match your query one by one, and then it will return the result. But in case of capped collection, it is already indexed, so it will not go and search for all the document. It will work as a index collection. Okay, automatic removal of oldest document that we have seen. So how and where we use this? We use this to store log information. Suppose your application is running and you want to store the log information for suppose 1000 transactions, so you can put a document for storing the log and you can give it a max limit 1000. So whenever 1000 transaction has been added to the log file, the next 1000 first will be inserted and the first one will be deleted. And to store the cache, small amount of data in the capped collection, that also to store the cache transaction data, that we can use the capped collection. Underscore ID field will be always there in the capped collection when you insert a document. That is always there in the MongoDB, and index on underscore ID field will be by default, so no need to worry about the indexing the capped collection. And update, if you plan to update the document in a capped collection, create an index so that these update operations do not require a collection scan. Document size, if update or replacement operation changes the document size, operation will fail. Okay, so if you try to update or replace the document size, it may fail. Okay, and here document deletion, you cannot delete document from capped collection. To remove all documents from a collection, use the drop method to drop the collection and recreate the capped collection. So once you have created a capped collection, you cannot delete a particular document from that capped collection because it will maintain the insertion order. So to maintain the insertion order, it will not allow you to delete a particular document, a single document. So if you want to delete, you have to drop the entire collection and you have to recreate the collection again. Okay, sorting, you cannot sort a capped collection. Okay, then query efficiency, use natural order to retrieve the most recently inserted elements from the collection efficiently. This is analogous to tail on a log file. Okay, aggregation pipeline stays out, cannot write results to capped collection. These are the things are not important if you are starting with the MongoDB. And let's see how we can create a capped collection. Okay, so let's go to the cell. So this is the Mongo cell I have already opened. What I will do, I'll just clear it, and what I'll show you, so DBs. So what I'll do, I'll use test DB, and here what I'll do, I will create a new collection, db dot create collection, and for this collection I'll give a name. Suppose I'll give a name cities. Okay, I want to store the cities name, and after that what we need to give, we need to give capped, and we have to make it true. So when you use capped true, it means you are creating a capped collection. Okay, see here. And then another mandatory thing is size. We need to provide the size, so you can give size. So this will be in KBs for a document size. This is compulsory. And then we can give another argument here, max, and here we can give the number of maximum document allowed inside this capped collection. Okay, so suppose what I'll do, I'll just give cap true and max size 3. What will happen? It will throw us an error. See here, now it is throwing us error and it is saying size field is required when cap is true. So size you have to give compulsory. Okay, so here we need to provide the size. Okay, now if I hit enter, see here now, okay, that means our capped collection is created. So I'll just use so collections. See here, now we have 2 schools I have created earlier and cities I have created now. So now let's insert something inside the collection. Cities, db.cities.insert. I'll use insert 1 here and I'll try to insert suppose I'll insert city name and I'll give, suppose I'll give Lucknow, and if I hit enter, so that is inserted. Let's query that db.cities.find. so see here now 1 city is inserted. Next I'll insert another city name. Suppose I'll insert Sydney. Let's query again. So now 2 document inserted. Let's insert one more. We'll insert London. Hit enter. So now let's query. See here now 3 documents has been inserted and we have given the restriction of 3 documents, right? Max 3. So let's see. I'll try to insert one more. Suppose I'll give New Delhi. Hit enter. See here now the New Delhi acknowledged true means New Delhi is inserted. Let's query and see what happened to the Lucknow. Earlier Lucknow, Sydney and London were there and 3 allowed and 3 were already there, and New Delhi we have inserted. So let's see what result it is giving. See here, now it is giving Sydney, London and New Delhi. Lucknow document has been deleted and instead of Lucknow we have the New Delhi, right? So Sydney becomes the first document, London becomes the second, and New Delhi, the newly inserted, will become the third, and the earlier first Lucknow has been deleted. Okay, so this way the capped collections work. Let's see what else we can get from the documentation. See here, to check if the collection is capped or not, we have to use this query. So let's copy this and db dot our collection name is ct dot is capped, and see what it is returning true. Okay, suppose I'll create one more collection. Use country dot insert 1, and here I'll insert country name India. Okay, and since I have not given any capped constant to this country, so let's see how it is responding. See, it is false. So capped is false because while creation of this collection we have not given any capped arguments like we have given while creating the city. Cap true, max size 3, like this. Okay, so when it is, if you want to see which collection is capped and which is not, you can use this method, this function each capped db.collectionname.isCapped, and it will give you true or false. If it is capped, it will give you true. If it is not capped, it will give you false. That's it for this lecture. Thank you.